Hey, it's Mr. Lum again, and we're going to be continuing on with some more Chemistry 11, and we're going to be talking about Avogadro's hypothesis. Um, so Avogadro was a very famous scientist, and he had this hypothesis that was later proven to be factual. And he said that equal volumes of a gas at the same temperature and pressure contain the same number of particles. So if you had two um, containers, okay, and if they're both say 1 liter, and they're filled completely with one type. This was completely filled with one type of gas, and this was completely filled with a different type of gas, and they're the same temperature and the same amount of pressure. They're going to contain the same number of particles. Now, they might not be the same weight. In fact, they probably won't be the same weight, but they will have the same number of particles. And then later on, it was said that, well, if you have 1 mole of any gas, and if you remember from our last lesson, 1 mole is equal to 6.02 times 10 to the 23 particles. So if you had 6.02 times 10 to the 23 particles of any gas at STP, standard temperature and pressure, that's going to have a volume of 22.4 liters. So 1 mole at standard temperature and pressure is always going to have a volume of 22.4 liters. Now, what is standard temperature and pressure? Well, standard temperature is 0 degrees Celsius. Okay. Standard pressure is 101.3 kilopascals. So at this standard temperature and this standard pressure, 1 mole is going to occupy a space of 22.4 liters. So here is our question. What is the volume of 0.870 moles of CO2? So we're going to write this out. We're going to go 0.870 moles of CO2. We want to know what the volume is. So I don't want to know the moles of CO2. So I'm going to go moles right here. So when I have moles divided by moles, I know that this is going to cancel out. And the unit that I do want is I want to have liters. So this is going to be 22.4 liters is equal to 1 mole. And so all I have to do is use my calculator and go 0.87 times 22.4 divided by 1, which you don't really have to do, I guess, is going to be 19.488 liters. Okay? Now, if we remember our significant figures, we have to go, well, this is 3 significant figures. Liters is a volume, and that's a measured unit, so this is also going to be 3 significant figures. So it's 3 sig figs, 3 sig figs. Now 1 mole, this is just part of our definition. Okay, so this has no sig figs. So it's 3 sig figs and 3 sig figs. So this is going to have to be 3 sig figs. So this is going to be 19.5 liters of CO2. Okay? So let's get into a little bit of a harder question now. Here's one right here. It says there are 10 grams of carbon monoxide gas at STP. What is the volume of gas present? Okay, so first thing is that we have to find the molar mass of this. So molar mass of of carbon monoxide is going to be, well, it has one carbon and one oxygen, so it's going to be 12 plus 16 is going to be 28, so it's going to be 28.0 grams in 1 mole, and that's what is the molar mass of carbon monoxide. So what we're going to have is we're going to have 10.0 grams, that's what it says here, of carbon monoxide, and first off we're going to change this. We're going to do a little quick unit conversion between grams and moles. So I want to have moles on top, so I want grams to go away, so I'm going to put grams on the bottom and moles on top, and so therefore there is 1 mole is equivalent to 28.0 grams. So therefore my grams is going to cancel out. Now I don't want to know how many moles of carbon monoxide I have. I want to know the volume it's going to be taking up. So I'm going to multiply this again by, well, 1 mole is equal to 22.4 liters. So I always put the units that I want canceled out on opposite sides, so it goes mole divided by mole. If I put it up here, it'd be like mole squared, which is incorrect. So grams cancels, moles canceled, and my final unit is going to be liters, and that's what I want. I want liters, or in other words, I want to find out what is the volume of gas that I have of carbon monoxide. So in my calculator, I'm going to go 10 divided by 28, and then I'm going to multiply that by 22.4, and I come up with the number 7.999, and it goes on for a little bit. So I have 3 sig figs, so I'm just going to write this in blue, 3 sig figs, none here, but this is 3, this is 3 right here, okay? And so the actual number I get in my calculator is 7.9999987. So we have a lot of numbers right here, but we need to change this into 3 sig figs. We need to have, these need to be 3 sig figs. So this one's going to round up here, and so therefore, if after I change this into 3 significant figures, it's going to be 8.00 liters. This is 3 sig figs of carbon monoxide. We should always write what kind of chemical we're dealing with right here. Okay, so we had to do a unit conversion in order to get our grams of carbon monoxide into moles, and then it was another little conversion to get it into liters. Okay. Now we have another question right here. It says there are 0.635 moles of CO in a room. Then someone runs an engine for 4 minutes and puts another 0.21 moles of CO in the room. What is the total volume of CO? What is the total mass of carbon monoxide? So when we take this question, we're going to imagine that everything here is at STP. Okay, for chemistry 11, we're going to say everything here is at STP. So the first thing is that we have some existing carbon monoxide in the room, and then more is put into the room. The amount of time that it takes to put this carbon monoxide into the room doesn't matter. So we have to find the total amount of carbon monoxide in the room after this engine has run. So what we're going to do is we're going to just go 0.635, and we're just going to add 0.21. Okay, and after we add these two numbers up, we find that it's 0.845 moles of CO. what is the total volume of CO? So I have this number right here, and so I'm going to take 0.845 moles of CO. I want moles to go away, so I'm going to put moles on the bottom. And 1 mole, as we know, is now equal to 22.4 liters of gas. Okay. And therefore we can find out what is the total volume. So the first question, the first part of this question says, what is the total volume of carbon monoxide? So I'm going to go 0.845 times 22.4 equals, and I get 18.928 liters. Okay. The next part says, what is the total mass of carbon monoxide? So I'm just going to take this number. So this was our part A, if we want to write like that. And our part B is going to be, well, we have again 0.845 moles. We want to know what is the mass of this. We want grams. So we want moles to go away. 1 mole is equal to, we figured out the molar mass from our last question. Okay, this is carbon is 12.0, has an atomic mass of 12.0, and oxygen is 16.0. If we add those up, that's how we got 28.0 grams per mole right here. And now I'm just going to go 0.845, so 0.845 in my calculator, times 28 equals, and I get 23.66. Oh, I made a mistake here. It's not liters, it's grams. So 23.66 grams I have right here. So for our part A, what is the total volume? 18.928. And what is the total mass? 23.66. Now we're not quite done yet, because we always need to think about our significant figures. So going way back at the beginning, we have our total moles right here. Now we're adding this amount of moles to right here, this amount of moles, and we need to use our adding and subtract rule. So I'm going to draw I like to call it my line of significance. And so this is actually 2 significant figures. Okay? Now, the reason why I keep all of these numbers here is because if I start rounding at the beginning of my calculation and I start rounding each and every single number, then my final number is going to be very, very different. It's going to be not very accurate. So I don't round, but in my head I keep and I understand that this is 2 significant figures. This is 2 sig figs. Even though I'm kind of rounding as 3, I will just report it later. Now this is 3 sig figs. So my final answer needs to be 2 sig figs. So 18.9 is going to round to 19 liters of carbon monoxide. Okay. Again, this is 2 sig figs, even though I wrote down 3. I just want to make sure that my final number is more accurate. So again, this is 2 sig figs, 3 sig figs. I'm multiplying here, so I use the multiply divide rule. And I realize that 23.66 is going to round to 24 grams of carbon monoxide. Okay, so a little bit of a tricky sig fig part right there. Anyways, that's it for today.